Welcome to Danny Speaks Physics, and we're going to talk about Einstein's length contraction. Ever wondered what happens when objects move really fast close to the speed of light? Now, this is exactly what Einstein came to think about, and when he did think about this, he came up with a theory known as the theory of relativity. Now, specifically in the special theory of relativity is where Einstein came up with one of the two most fundamental principles in relativity. One of them being that the speed of light is always constant throughout the universe and nothing can surpass this speed. And not only that, but the fact that the laws of physics are the same in objects that are in uniform motion, or also known as inertial frames of reference. Using these two concepts of relativity, Einstein made a very fascinating prediction in that when objects move close to the speed of light, their length shrinks. That means tall objects become shorter in the direction of the motion. When a rocket flies through Earth in speeds really close to the speed of light, an observer from Earth watching this rocket ship pass across the atmosphere will see this object shrinking. That means we don't usually observe this throughout everyday experiences, because achieving length contraction in reality really needs speeds very, very high, speeds that are really close to the speed of light. Now, in ordinary sense, we don't really achieve this, and in fact, the fastest objects traveling around Earth don't even make half the speed of light. Now, you can never actually observe this in everyday experiences, but this theory is well established, is well proven, both theoretically and experimentally. And now, why does this happen? Of course, there is a formula for this. Now, apart from the formula, the physical sense of why this length contraction occurs is the fact that there is a relativity in simultaneity. Now, how does that occur? How does that form is actually not in the scope of this video, but you can try to understand that the universe somehow tries to balance, that tries to restrict objects from achieving the speed of light. And what's the best way to do this is to make objects shrink in size in such a way that an observer looking into an object moving closer to the speed of light will see the object shrinking in size. Sometimes in life we wish to be thinner, we wish to be smaller, at least pass through things where some people can't, you see. Now, if this was actually possible to actually harness the power of length contraction, we will actually need to know the basics and the formula of length contraction. Now, from the formula, we have L naught and L, which being the initial and final length of the object respectively, plus the U and the C, and the U is the speed of the object and the C is the speed of light, which is constant. Now, to actually get a really good meaning of this formula, the term U has to be really large compared to C. That means to actually get close to C, so that all the term under the square root could actually have an influence on the final length L on the other side. We see a lot of this in movies, like The Flash and other movies, where like the superhero kinds of like vibrates and manages to pass through things where normal people can't. Well, they're actually using the concept of length contraction. Now, when you do this, you vibrate in such a way that you vibrate to speeds closer to the speed of light. You may actually achieve length contraction, become thinner, and pass through thin objects, thin walls, and do things that other people can't. The length contraction is actually a very fascinating concept because it helps us think about very, very interesting paradoxes. One of them being the ladder and the barn paradox, which I think will be explained in upcoming videos. Now, thank you for listening. Thank you for being around here. Don't forget to like, don't forget to subscribe, don't forget to hit that notification button to getting updates of the latest videos concerning physics and cool theoretical physics, just like this one. Goodbye.